Hi, everybody. Welcome to the Genetics Podcast. We had a last minute cancellation for this week's episode, so we didn't want to leave you hanging. So we brought back one of the very first 10 episodes. It's episode number 10 with Eric Topol. We wanted to bring this one in particular back because it's so far back in the archives, we think that most of you probably haven't had a chance to listen to it yet. And if you haven't, Eric is a world leader in machine learning, cardiology in particular. He's had a very long and illustrious career at the intersection between cardiovascular disease, genomics, and other next generation technologies. For a second reason, AI is having a really big moment right now with ChatGPT that we've talked a lot about. And as we know, there have been impacts of machine learning and artificial intelligence in medicine and in life science research to some extent, including things like AlphaFold and a number of different applications in the healthcare system. It does seem like we're at a moment right now where we might be at an inflection point and a lot is changing. And Eric has been spending a lot of time thinking about this over the last 5 to 10 years. And we spend a lot of time on it in this episode that was now more than 2 years ago. So I think it will be an interesting look back into what he was thinking about then. And then hopefully you can use this to contrast with what we're seeing now. So thanks again for listening. We hope you enjoy. And as always, feedback on this episode and any others is very much appreciated. So thanks so much, Eric, for coming on the podcast.
It's great to be with you, Patrick. Thanks for having me.
Great. So to start off, I thought I'd hit you with the most challenging question. You have I think, a pretty incredible vision for the future of healthcare and medicine, and it involves artificial intelligence and machine learning. But the way you see it is, I think, actually very different from what many people think. So I was wondering if you could maybe just paint a picture for us now of how you see the world of medicine and healthcare being different a decade from now. What will life be like for the typical patient?
Well, it comes down to that there's immense data for each of us, and it spans not just the traditional medical data that might be in a record or records that are dispersed in many different places, but it has sensor data, our genome, our gut microbiome, our environment, and all these different layers of data. I mean, I haven't even mentioned some of the biology layers like the immunome, whatnot. So basically, that is transcending human capability of ingesting and dealing and analyzing such data. And that is going to be the future of medicine, where we rely more on machines to do that, to help us, to gather it all and crystallize it, distill it. And that will make for individualized medicine, which is very different than the way medicine is practiced today, which is essentially dumbed down and very shallow.
Right. And I think one thing that I've heard you talk about before, which I find very promising, is that you don't see this influx of data or precision medicine as replacing the doctor, right? Actually, you see it as empowering the doctor to be more present and more human interaction, right? Less typing on the keyboard.
Yeah, that's actually the whole theme of Deep Medicine, which is the book about how AI could transform medicine, that is, bring back the care in healthcare, and as you've touched on now, which is this gift of time, this efficiency, this accuracy and speed, all turned inward so they can reestablish the presence, but the trust, the depth, and the empathy, communication, compassion, all the qualities that are the essence of medicine, which is a human factor. It's a human story that we have lost over time. We can get it back, though. We don't really have any other path to get it back that I know of, except this one.
What do you see as the kind of low-hanging fruits, or what are the first things that'll happen that will mark this transition? Or maybe some of them are already happening today.
Well, some are happening. Today, the first things that we're seeing are things with patterns like medical scans that are now getting pre-read by a machine before the radiologist sees them. And that is great because over 30% of scans have a missed finding, a false negative. So that rate can be dropped much lower. And that's getting a lot of uptake. It's a positive thing. But we're also going to see that same sort of accuracy and speed applied to many other specialties. Pathology, dermatology, ophthalmology, and then most recently the randomized trial in gastroenterology, that is colonoscopy, to pick up these small polyps that could be precancerous at a rate that is extraordinary, that are missed by the doctors. So, this big improvement of accuracy and efficiency is welcome. We need that.
Right. And I guess in some of these cases, it's so complex to learn how to do these things, to read the scans. And if you incorporate other data, for instance, someone's genetic background or other information, it can quickly become overwhelming anyways, right? So this is an area where leaning on computers or computational power can hopefully, help people rather than replace them, right? And I got that from your review of the NHS and the future, right? That this isn't something that threatens jobs, but actually it's almost makes the doctor have superpowers, right? You have the weight of a cloud computing system behind you, and that helps you be better at everything. Is that?
I think you're right, Patrick. That the issue here is that you could have doctors who have superpowers, but the problem we have is we have these managers and administrators, and they could say, well, now that you have superpowers, we want you to read 10 times more scans and see patients 10 times more quickly.
Right.
And if we do that, then we've lost all the benefits. So what we have to do is figure a way to turn inward and use this great and maybe once in a lifetime, once in many generations, if ever, to have this opportunity, seize it to bring back at least in my view, this crucial, pivotal human bond that it's largely been lost over the decades when medicine became such a big business, if you will, where productivity became the overriding concern rather than the human factor.
Where are people doing this best? Where should we look for an example? I think it's probably not the US at the moment, right? Is it maybe Estonia or somewhere where they're digitizing everything, or is the UK doing it well?
Well, each country outside the US has attributes that are noteworthy. So as you mentioned, Estonia is leading in terms of digitization of all of data, and each person, each citizen of Estonia owning all their data, whether it's their genome or
Right.
their sensors, they own it and they can share as they see fit, when and how much and who, all the things that are ideal in my view. The UK is leading the charge in certain areas. They're the first to make the voice recognition a reality instead of typing on a keyboard in emergency.
Oh, really?
Yeah. So that's exciting because we're going to eliminate keyboards someday. And everyone talks about going paperless, and we've never really been paperless. We got to go keyboardless because it's the keyboards that are the common enemy of the people.
Right.
That is patients and doctors. And that is the first step of getting eye-to-eye contact and presence and, real human interaction. So Leeds there in the UK, the emergency department there was the first in the country, and well before anywhere in the US. In China, there's a lot going on in AI. In many of their big hospitals, they are, using AI for many different purposes. Part of it is out of need. They have much less doctors. They have obviously a massive population to have to. Some of their hospitals, instead of what you'd see in the UK or the US, they could have 10 to 20,000 people.
Right.
Bed. So I mean, they have
solving problems.
Yeah. So AI, China is using AI at the moment in more ways than other countries, and we can learn from it too.
How do you see genomics fitting into all this? That when you mentioned things the UK is doing well, that struck me as one of those examples there. I still do rare disease genomics research, and they're certainly leading the way in national scale diagnostic sequencing. And now they say that in the next 5 years, they're going to try to do 5 million genomes. Is this in your mind, a big growth area and where other people should be looking?
Well, I first to say the UK is the world leader in genomics. There isn't any question about that. Yeah. And the reason, of course, is they made a big investment initially with the UK Biobank,
right?
Now with Genomes England and the other initiatives that you mentioned. So every day now, it seems, there's a new paper that comes out in genomics.
Biobank, yeah.
These are the UK Biobank data. So it's extraordinary. And we're learning so much so fast by having that resource, that information resource develop. And it's been extraordinary. So the other thing that's interesting in the UK about genomics is that there's a division of the NHS, the Health Education England.
Right.
We don't have anything like that in the US, nor do I think most other countries. So you are actually training the medical community, the professionals across the board, all clinicians, about genomics. And that helps, of course, to get this into the mainstream and the high gear. So that's why you have an edge that's just extraordinary. And obviously, that's my favorite topic is genomics, of course. And so I have the highest regard. And when I did the review of the NHS, I had two co-chairs who are friends of mine, Sir Les Samani and Mark Carthy at Oxford. And I got a really deep sense about the commitment there. And not just for what has been accomplished, but where the leadership will be sustained.
What within the field of genomics, what are you most excited about? Is it, I know you've done a lot of work in the safety of different drugs. Was it pharmacogenomics, doing a better job stratifying people into you're likely to succeed or identifying those that are going to have safety issues? Or is it early detection through things like polygenic risk scores, or is it something else?
Well, I will just get into the polygenic risk score. I think is a big area. But I just want to preface it by back in end of 2006 when I came to Scripps, the idea was, well, we're going to start a human genome institute, which we did. But it was a few months later, here is the center of wireless with Qualcomm. And there's not just that's the largest company in San Diego, but there's hundreds of derivatives of people, right, engineers that used to work at Qualcomm that set up these wireless companies, a lot of them in medicine. So very quickly I said, wait a minute now. We're obsessed with genomes and the genome sequence, but that is not the whole story.
No, it's just
one level up, one dimension, an important dimension, of course. But why don't we start getting into sensors? And the thing that was the eureka moment was I was at a meeting early on when I got here in 2007, and there was it was organized by Qualcomm. It was about smartphones and how they're thinking about putting a camera in the smartphone. And I'm sitting there, I'm in the back of the room. All of a sudden, I woke up and said, whoa, wait a minute, that's a sensor. And all these people were arguing that why would you need to have a camera in the smartphone? Because we had these point and click, really good cameras. And I'm thinking, wait a minute, this smartphone could be a medical device.
The diagnostic device, right? Yeah.
Yeah. So I said, well, wow. We decided to change our institute from one that was not just genomics, but also digital.
Right.
And so I think that was a pivotal thing for us because we were early on, a center that fostered the notion that DNA sequence, while vital information, is not enough. And the physiology that one can get from a wireless wearable sensor with continuous output is of exceptional value as well. And so this was the beginning of all these different layers of data. Now, getting back to the polygenic risk score, that I think is really ready to be used in common practice. It's complementary to our normal risk factors. It's independent. It's useful for many common conditions, particularly heart disease, but other things as well. And I think we should be using this because that's my biggest frustration in genomics. You mentioned pharmacogenomics. We have all this data and all these wonderful papers in prestigious journals, and we just keep it locked up in the research world, and we don't take it out to the real world and help people. And to me, that's really frustrating. And I think polygenic risk scores fit into that category, that it's ready to be used. And we shouldn't be so paternalistic about, oh, well, there's these nuances. Well, of course, there's nuances with anything that we use in medicine. Let's get it out there.
What do you think is the biggest hurdle to that happening? Because as you say, here in the UK, there's probably 500,000 to 1 million people who've done direct-to-consumer tests. They're not perfect, but they can be used to calculate risk scores of many of these common diseases. In the US, it's probably 4 or 5 times that many. Do you see this as something that has to initiate through the healthcare system, where the data is generated there and analyzed there? Or what's the biggest hurdle to actually, because the data, as you say, the data exists actually for a large fraction of the population, but it seems to me like it's actually getting it into the healthcare system and having to be recognized.
I don't think there's any obstacles. I mean, we have a mobile app, My Gene Rank, and if you upload your chip data, your 1 million SNP array into that, you can get your risk score for heart disease. And over the next several months, we're going to have breast cancer, prostate cancer, colon cancer, atrial fibrillation, type 2 diabetes, so all these common conditions, right? So the real issue here is that there is an unwillingness to put the data out there because the issue is, oh, well, people will know they're high risk. Is that going to change their behavior? I actually think we have evidence that it will. We have a Finnish study of heart disease polygenic risk score where a large proportion of the people at high risk, they stopped smoking or they lost weight or they did things that were clearly changes in lifestyle that were specifically because they were at such high risk. We do know that if you take action, if you have high risk, polygenic high risk, that you're going to titrate that risk and lower it. So we should be using this stuff, and I think the biggest obstacle is the ancestry.
Right.
We only have data that's compelling for European ancestry because the UK Biobank, on which basis most of the data comes from, was a European ancestry story. We really need the African and Asian ancestries that are not nearly as well developed, and that's our obstacle. Is like somebody who is of non-European ancestry wants to get their output, and we don't really have it yet.
Yeah, I think that's absolutely right. Do you see this, is the solution to that problem, do we have to wait for researchers to amass enough quantity of data to get these algorithms to the point where they're equitable, or do you think they can be launched into the healthcare system with emphasis put on collecting the data to make them? Because that seems like a hard part about it to me. Can you launch something that that we know a priori isn't going to work as well for everyone?
Yeah, no, you're right. We do need more research. You can't really impute this. I mean, just today there was a really nice study on Titan for heart disease, and it has amazing impact in European ancestry and almost none in African ancestry for heart disease. So you might not have known that until you had enough people you studied. Of course, you can't project a lot of these things. So we got a really great review in Nature Review Genetics showed that only a little over 20% of the people so far of the millions who have been studied are of non-European ancestry. We got to fill in the blanks, and it's going to take some work, but it's eminently doable.
Yeah, I think so too. You touched on there this issue of potentially overdiagnosing. So you gave this great example of Titan, and you might have thought that for everyone it was a risk factor for heart disease, but if it turns out that for part of the population it's not, or there's plenty of other examples in other conditions, do you see this as a problem that might be exacerbated by genomic technologies, or is it actually going to, and maybe artificial intelligence in general, are we going to do a better job at determining what we should really be worried about and flagging less of the things that we shouldn't be concerned about? Because that ultimately adds a huge amount of cost to the whole system, right? Treating things that we shouldn't really be treating.
Well, it's just like a medication. It might benefit a patient and might have side effects. Information's a lot like that. If it has a big net benefit, then it's worthy. And so what you're getting at is, if you have this information, it helps a lot of people, and then some people, it winds up being misleading. As long as it's not, especially injurious, it will be a favorable trade-off. I don't know anything in medicine that's perfect. That it's always some kind of liability. So we want to accept that, and I think that's what this is about. That polygenic risk scores of these hundreds of SNPs that are for each condition that were of interest, when they're actionable. I'm not talking about things like Alzheimer's or obesity or things that you might not be actionable. Once you look at the ones that are, that is, if you are at high risk for a cancer, then you might have a whole different look as far as your screening and your modulation of lifestyle. So the ones that are actionable, it's a net positive information. Will some people get misled? Yes, but it isn't like it's going to give them the disease. It's just, we got to keep that in mind.
Yeah, and it's concern and extra screening, but as you say, on a population level, you have to do what's right to identify these things as early as possible so we can treat them.
Yeah, it goes back to that theme of that the medical community is too conservative about bringing out data for the benefit of the public. And it's maybe the most vexing, that and the fact that people don't own their medical data are right on the top of my pet peeve list.
Yeah, I don't know if this is true. I'll have to double check it, but I was told that when the at-home pregnancy test was first launched, that there was a lot of skepticism of whether people and women in particular could handle being told they were pregnant in the absence of a doctor. And after I'm sure a decade or so, it became that this was not an issue and people could handle it.
No, you're right. There was a revolt that women wouldn't be able to handle it, and people would be in disarray, and it took a long time to get settled, like any other major change. But that is what you're getting at, is we underestimate what people are capable of doing.
Yeah.
And we got to get over this problem. I mean, time after time, pregnancy, HIV, self-testing. I mean, there's so many things that we didn't think that the public people could handle, and every time they handled it perfectly well.
Right. You just mentioned this idea of people owning your data, which is something that I'm also really interested and passionate about. I was curious, when you use the term "own your data," what do you mean by that? Because different people, actually, I've found have different definitions of what they mean, because owning your data is kind of different in some sense than owning a bicycle, because it's infinitely copyable. So when you say own your data, what does that mean to you?
Well, in my view, it's the Estonia model, whereby you do get to parse it out, and you could share the relevant parts to a certain doctor or a research study, and other parts you wouldn't share. I acknowledge that you can copy it. That's fine. And there's like this co-production model where you have this relationship with a doctor, which hopefully is going to get better than it is today for most people. And you obviously, the doctor has all your data too, because you trust that person. But let's say you're going to a new doctor, and you're sizing him up,
right?
Him up or her up, and you don't know whether you're going to trust it. You may not want to give them all your data. But the point is, there's so much problem of people not having their data. So in the US, for example, people don't have their scans. And so over 10% of scans, which is ionizing radiation, which is expensive,
Right.
they get duplicated just because the patient doesn't have the scan and can't get it from the health system, from whatever doctor that did it. And that's billions of dollars of waste a year. That's just one example of why this is so ridiculous. If every person had all their data, which they entitled to, and no one is more appropriate to have all their data. If you want to own it legally, sure, make it legally their property, fine. And yes, it's going to be vital that be shared in order to execute the care of the person. But let the person make the call. And I think that we don't, again, we as people have been in suppression mode of the medical rulers. They have been, doctor knows best, and we have been the little people. And I see that from both sides, because like when I've been a patient and for me to get my scans or my data, it's like, begging at the trough to get my own data. So we have to start to say, wait a minute now, we're all people, and there's nothing about the doctors that why do they legally own my data? It's absurd. They say it's it's their note because they did the note. Well, guess what? It's my body.
About you. Yeah.
I know. So these are attitudes. You know what? By the way, Patrick, someday this is all going to be looked at in a comical way.
Yeah.
Doctors thought they owned everything in the hospital. Wrong. It's the wrong attitude. It has to get fixed.
Yeah, I think you're absolutely right. And the point that you made about people actually do own their data is one that's often missed, whether it's under HIPAA or GDPR, that you can pretty much always request your data and they have to honor that request, right? So it seems to me like it's more of an issue of infrastructure than it is any kind of legal or regulatory issue, right? It's just that the system right now makes it really easy for data to stay in one place and not move, and really hard for it to travel towards the patient or flow through the system.
Right, exactly.
I've seen this as well in diagnostic sequencing for rare disorders, for example. If people don't get a diagnosis from one particular project, they'll often be enrolled in a second or a third, or they may even go to a private testing company and buy a test. But actually, it's an exome sequence every time, so they'll have an exome sequenced 3 or 4 times.
Yeah, no, it's a really common problem, but we have to get over this hurdle. Yeah.
Do you think that we will live in a world where people are transacting in their genomic and medical data? This is a topic I think that has come up not just in health, but in other parts of the economy as well. Do you see that as, if you look forward 10 years, like we were discussing at the beginning, do you think we'll have marketplaces for this kind of data, as some people suggest, or do you see it going a different way?
Yeah, that's a good question. Right now, of course, you're starting to see that crop up where you could get paid to give your data. I don't know how that's going to play out. Whether that's just a passing fancy. What I like about it is it's showing that people's data has value, instead of the prior notion that the doctors and hospitals, health systems owned everything. And,
right.
So that is a good reflection of where we're headed. Whether it's durable, I don't know. And I do think people should have the right to sell their data if that's their choice. The question is, will there be a market for that eventually? I don't know.
Yeah, and I think that's a good way to put it. The way I've always felt is that people should absolutely have a right to sell it, but I think in many cases it actually runs counter to people's primary motivation for participating in research, for example, that if you have a condition, then the first thing on your mind is typically, is participating in this going to help me or help my child, whether it's enroll in a trial or learn something more. And the financial benefit may be secondary to that. So that's what I've always thought. But the counter argument to that is there are some examples where, particularly for select conditions that might be rare but lucrative in terms of the economics, that someone has made a huge amount of money selling medical or genomic data, or the combination of the two. And I think of the Henrietta Lacks story, that it's a good book, The Immortal Life of Henrietta Lacks, that the amount of money that was made from the cancer stem cells, or the HeLa cells that were taken unethically over the many decades since, is probably an astronomical amount. So you could imagine if there was a structure in place where the family had a license to that data, how potentially life-changing that could be. But that's the power of a story, I guess, and may not translate to the whole economy. But I don't know. Have you?
Well, I do think that that book, which is a superb book that you're mentioning, The Immortal Life of Henrietta Lacks, is indicative of our times. That was a time, when at Johns Hopkins, where I did some of my training, where there wasn't respect for patients, and now they're gaining more and more respect every day, and this equal playing field of we're all in this together, and that we're all at equal footing. That's the democratization of medicine, and that's an inevitable story, because when data is eminently portable, then it's no longer I own it. Now it's ours. It's ours collectively. And in fact, who to direct the flow of that data is more the issue. I actually think this is a big movement of our time, because in the world of artificial intelligence, it's all about this. Most of it's about deep learning, and that's an input-output story. So if you want to put in not the full picture of all your data through these neuronal layers of that discern the features, if you have compromise of data, it's not the complete story. What do you get as an output? Suboptimal. So if people don't have all their data, which in the U.S. no one has all their data, because they go to different health systems and different doctors throughout their lives, and they move, and so nobody essentially has all their data, perhaps is with a rare exception. In other countries, they do have, because there's a single health system where at least they're capable of having all their data from birth, or even pre-womb, pre-delivery to throughout their life. In order for AI to click and to deliver its maximum value, you want to have absolutely complete data sets for each person. We're far from that today.
Right. Yeah, and it'll take some time, won't it? But some places are certainly ahead. You gave the example of Estonia. Finland, I think, is another example where they've constructed the system from the ground up to actually enable this.
That's right. Switzerland, Sweden, I think other countries are getting on board with this.
Right. I know we're running short on time here, so I just had two quick questions that I wanted to finish off with. The first one was, for anyone who's listening who's a student getting ready to start university, start a master's program, maybe a PhD program, or thinking about going back to school to study something else, what would you study today if you could start all over?
Well, when I was in college, I studied genetics, and I've never lost my interest in that fascinating area. You can never go wrong with that. But I think the added areas of particular interest today are computer science. So if we go back to genetics, that's so rich with CRISPR and genome editing and the microbiome and metagenomics. I mean, it's such a hot, sizzling area, and equally so is AI. That includes deep learning and natural language processing and nearest neighbor analysis and all the other components of computer science. So, those to me are the two most exciting areas of life science. And I should also point out, it's not just medicine we were talking about. The idea that you could find rare cells through deep learning, that you could look at a slide without staining anything, that you could see everything. I mean, it's having effects in science. Life are extraordinary and are moving much faster even than medicine. So that would be, if I could go back. I mean, I had to learn computer science to write the book Deep Medicine, but I wish I, of course, was grounded more in it.
Right. And then the second question was if you were a patient or a parent of a patient, and you wanted to accelerate progress toward this future that you described, where everyone owns their data, and we have a future or medical practice that's built around personalization and leveraging this data. What can you do today to help push that forward?
Well, first step is calling all your data together. So if you don't have it, get it together, whether it's for your child or whether it's for you, because that's just going to become increasingly important. And in the book, Deep Medicine, I tell the story opening in the book about, when I had a knee replacement, all my data were not readily gathered, attainable. And that influenced my real complications of post-operatively. So, this is really important. That's the first step. And then hopefully what we'll see is this enhanced humanity, this better patient-doctor relationship, and to try to drive that. Demand more time, demand more communication, hopefully a lot more democratization as we go forward.
Great. Well, before we go, I just want to give everybody a chance to follow you in case they want to keep up with your work. I personally follow you on Twitter, and it's a goldmine of new scientific research that you share and thoughts on the industry. I feel like you must read constantly because you're putting out 10, 20 papers a day, but that's part of your job, isn't it, to just keep up with this stuff?
Yeah, probably not more than 10, but, somewhere in the high single digits. I read a lot, Patrick, and I think that's important. And I've always been that way. I kind of an info junkie. And, but the difference is you probably read a lot too. You just don't or a lot of people you're listening, they don't necessarily tweet about what they read. So I just, if I read it, I tweet it. And as long as it's worthy, if it's junk, I don't share it. Or sometimes I share it just to take it down because it's so bad. But, I think that's what if we all shared what we read, we'd just get smarter faster.
Yeah, well, the first research paper that I published during my PhD, you tweeted about, and it was a very proud day in my life to see that come out over the airways. You highlighted it; it was very nice.
Well, at least you know what parts I really got into.
Yeah, what parts you liked.
It's fun when I read a paper that someone else that I wrote that someone's highlighted. I find that really interesting. Is what were the things that resonated? Yeah.
Yeah, absolutely. So it's just at Eric Topol, is that right, for Twitter? And is there a website that people can find you on, or anything?
Well,
else?
I'm at the Scripps research website, but if you really want to see what I'm thinking and reading, the Twitter is much better.
Okay, great. Well, thank you so much. We really appreciate it. A fascinating conversation.
Sure. No, I really enjoyed it, Patrick. You take care. Thanks.
Great. Thank you. Great. And thank you all for listening. As always, you can send any feedback, including questions you have, other guests you'd like to see on the show, or anything else that's on your mind to podcast@sanogenetics.com. We do read and respond to every email. If you like the podcast, we'd love it if you could share it with a friend. You could leave us a review on iTunes as well. No matter what, whether you like it or you hate it, tell us, and hopefully we can make it better. Then finally, feel free to visit our website, sanogenetics.com, to learn more about some of the projects we're working on right now. Thanks very much, and we'll see you next time.